In this video, we're going to take a look at notes for section 3.1 and 3.2. 3.1 is an introduction to functions, and then 3.2 is more about functions, which is domain and range. So the first section, an introduction to functions, just talks about what a function is, the definition. So I want to give you a minute to read the introduction. In many applications, it's important to determine how two different variables are related, where the value of one variable depends on the other. For example, in experiments performed by Galileo on free-falling objects led to the discovery of the formula S is equal to 16t squared, where S is the distance an object falls in feet and t is the time in seconds. In this case, the distance depends on the time. Another example is that electrical measurement of voltage V and current I through a particular resistor would show that V equals K times I, where K is a constant of variation from previous section. Here the voltage depends on the current. So the voltage depends on the current. So where this variable depends on this variable. T depends on S. In math, whenever the value of one variable depends on the value of another, we call this relationship a function. So definition, a function is a relationship between two variables such that for every value of the first, there is only one corresponding value of the second. The first variable is called the independent variable, and the second is called the dependent variable. We say that the dependent variable is a function of the independent. So up here, the independent variable would be t, the dependent variable would be s. In this example, I is the independent variable, v is the dependent. We're going to look at function notation. This s is equal to 16t squared can be written as a function of t. So we're going to look at notation that says if this variable depends on that one, we call it a function of t. So functional notation, function of x is written as f parentheses x. This means that y is a function of x may be written as y equals f of x. So all those times when we had graphs of lines, y equals 2x plus 1, x is the independent variable. Remember, when you make a table of values, you select whatever you want for x. Y is the dependent variable. Whatever you pick for x, y depends on what you picked for x. So we could also call that, instead of y equals, f of x equals 2x plus 1. So it's a different notation to identify this as a function. And then just a caution, f with the parentheses x does not mean f times x. It's just read as f is a function of x. Okay? So function notation, if y equals 6x cubed minus 5x, we say that y is a function of x. We can also write it with an f of x in the front. But it's more descriptive because it shows that the x value that corresponds to y. For example, f of 2 is equal to 38 gives more information than y equals 38 because it shows that when x equals 2, y equals 38. So whenever you have coordinates, f of 2 is equal to 38, 2 in this case is the x value that you choose. 38 is the y value that comes out after you substitute 2 in the function. So here's what that means. We would take 2 and substitute it into the formula and end up with 38. That means a coordinate on your graph when x is 2, y is 38. So you're used to looking at points as x, y on the graphs. So think about this. Instead of y, the coordinates are of the form x, f of x. F of x and y still represent the vertical axis. Okay? So let's practice using notation. If f of x is equal to 3x squared minus 5, find each of the following. So whatever we see inside the parentheses, that's what we substitute inside the equation for x. So f of 1 would equal 3 times 1 squared minus 5. F of negative 2 would equal 3 times negative 2 squared minus 5. F of r would equal 3 times r squared minus 5. It doesn't matter what you put. It says substitute that in the same position as x in your formula. This one means take 3 times x plus 2 squared minus 5. So that's all that notation means. So I'm going to go back. Let's simplify each of these. So 1 squared, 3 times 1 is 3 minus 5, gives us negative 2. That would give us a coordinate on the graph of 1, negative 2. Next, we get 3 times negative 2 squared is 4 minus 5. 12 minus 5 is 7. That would give us another coordinate. This, we don't get a coordinate. We just rewrite our function in a different variable. So now our function is our function of r instead of a function of x. Last example, we've got some algebra to do here. X plus 2 squared means x plus 2 times x plus 2. We have to multiply, but we don't have to. You can multiply these any order. But you can't multiply the 3 in the x plus 2 before you square it. Okay, so we get x times x is x squared. Outer plus inner is 4x plus 4. Distribute the 3. Add like terms. Then our function of x plus 2 evaluated at x plus 2 creates another expression. Okay, so function notation. You have a problem on homework that looks pretty complicated, so I wanted to make sure we went over it just a little bit. So on homework you have if f of x is equal to 3x squared plus 7, find f of x plus 3 minus f of x plus 3. Okay, so what does that mean to do? The f of x plus 3 means take x plus 3 and substitute it in your function. So I get 3 times x plus 3 squared plus 7. Let's just do that part. Square, take x plus 3 and square it. We end up with 3 times x squared plus 6x plus 9 plus 7. Distribute the 3. And then add like terms. We end up with 3x squared plus 18x plus 27 plus 7 is 34. So this is only this part. So I'm going to write it as 3x squared plus 18x plus 34. Now we want to subtract. I'll use a different color here. F of x, that means rewrite the function just as it was. F of x is 3x squared plus 7. So I'm just substituting for f of x the formula. And then it says plus 3. Now we can go ahead and simplify the expression. The minus in the front means distribute the negative through. So I get minus 3x squared minus, 7 plus 3 is 10. So that's minus 10. But I still have this expression. Now that I've got everything, all of the parentheses removed, now I can add like terms. 3x squared minus 3x squared cancel each other out. I'm left with 18x, 34 minus 10, 18x plus 24.